So today I'd like to talk about three-dimensional nanoprinting, and we had some allusion already to what additive manufacturing or 3D printing is, and so I'll go through that a little bit. But basically we have a three-person team with some students involved as well, myself as PI, Dr. Chris Williams from Mechanical Engineering as co-PI, and Dr. Ivanova as postdoc associate. So we're trying to understand the fundamental question of how to enable multifunctionality of 3D objects via additive manufacturing, 3D printing of nanocomposites. Basically, we are trying to enable objects to have form and function after the fact, be able to be changed in an object. So, classical three-dimensional additive printing or additive manufacturing is on the left. You take a laptop or a computer, you design an object, you go send it to the printer, and you print said object. Well, we have the vision of let's introduce nanomaterials into that object during the printing process, or sometime at some point prior to the printing process, create a new material, and then you're able to change the physical properties of printed parts after the fact, which is the multifunctional aspects. So the background significance, we have a successful completion of this research to lead to new contributions in nanocolloidal chemistry, and I can go into that if you like, and additive manufacturing, 5 major tasks. One of the exciting results we got very early on with Dr. Ivanova was the printing, or the colloidal synthesis rather, of quantum dots you see on the bottom right there. That is a set of cadmium selenium quantum dots, all the same material, all different sizes. Quantum dots have the capability to emit in different wavelengths of UV radiation, and so that's quite an interesting rainbow arrangement we can achieve. We utilize those quantum dots then to embed them into physical objects. So you see on the left, we printed a little business card-like scale, that's about the size of a business card, with Virginia Tech physically embedded into the object. So it's very thin, about 1.8 millimeters, but it is a three-dimensional object. And when you put that under UV light, it glows in the respective glow of the quantum dot, cadmium selenium quantum dot. To the best of our knowledge, that is the world's first embedded quantum dot three-dimensional printed object. And so that was quite exciting. And I should mention this is a collaboration between the Lens and the Dream Lab, myself and Dr. Chris Williams. So we have several technical highlights. We've published a major review article in Rapid Prototyping Journal, which is the major journal for additive manufacturing 3D printing. We've successfully synthesized quantum dots, and we have demonstrated the embedding of quantum dots in a 3D object, as I showed. An offshoot result that we got, which we were quite intrigued by, one day I was off in a conference and Olga emails me, Tom, I've got these strange square quantum dots. And I said, well, what is that? I've never heard of a square quantum dot before. But it turned out there were certain time temperature points during the synthesis process in which we could synthesize colloidally square or rectangular quantum dots. And so we undertook a exhaustive survey of the time-temperature relationships, and I can truly say optimized from an engineering perspective. I won't go into all the details, but we published this in Journal of Nanoparticle Research recently, in which we showed exquisite control of the shape of a quantum dot through the process. To the best of our knowledge, a world's first for colloidal synthesis of unique shapes of quantum dots. So, future research directions, we have the Lens team, the lab that I run, Laboratory Engineered Nanosystems. We're seeking to expand the possibility portfolio of materials synthesis, chemical synthesis, and mechanical synthesis techniques. We have a number of proposals pending, and I list a few below that we're under consideration with right now. The general quad chart here, you can read that at your leisure basically, but we've got several highlights I've already gone through. We've got a funded project with the CIT, Virginia Commonwealth Commercialization Fund of $200,000. That's a joint effort between Lens and Dreams Lab again. Department of Energy funded 2 awards to run a major 18 federal agency event at the White House Conference Center back on August 20th. It was a pretty fascinating event with 55 people. I had the first time I've ever run an event which I had to turn away almost as many people as accepted to attend. I mentioned the publication. I've got overflow sheets on all these things though, because I didn't want to make the font too small. We've given a number of invited presentations, and we've got a collaboration with Technical University of Munich, Germany, on a related topic of quantum dot plasmonic emissions. And We are also under discussions with MakerBot, one of the primary producers of three-dimensional printing systems out of New York City. And to not let anything go through or be left aside, listed the other funded projects I didn't go into detail about, specifically the TOMB project, in which we were awarded jointly with the International Graduate School of Science and Engineering, IGSE at TOMB, a 3-year PhD fellowship. And it's a PhD student who's been here, spent several months here, worked in our labs, worked in other Virginia Tech labs for his research. We've published 2 book chapters, myself and Olga, got a number of other refereed publications published, and just today we're submitting another article to Nanotechnology that's not listed there. We've given literally dozens of conference proceedings and other publications. This is quite a significant body of work over the last year or two. And intellectual property, we're aggressively filing intellectual property to ensure the commercialization perspective of this after the funding is executed.